For this video, we're going to talk about the atomic structure, which is the protons, the neutrons, and the electrons that are in an atom. Okay, and to start us off, we're going to watch a short video.
Although no one has yet found a way of getting a close-up view of an atom, different experiments have made it possible to build up a picture or model of what atoms consist of. The colours in these models are of course used simply to distinguish between different particles. In the centre of an atom is a nucleus. This is made up of even smaller or subatomic particles called protons and neutrons. The protons each carry a positive electrical charge. The neutrons are as heavy as protons but carry no charge. This means that overall the nucleus is positively charged, and orbiting around it are negatively charged particles called electrons. The size of the negative charge carried by an electron is equal to the positive charge carried by a proton. Now the electrons are moving at incredible speed, in fact 3/4 of the speed of light, so what stops them shooting off in any direction? If we could pull an atom apart into its components, we'd see that a neutral atom has the same number of electrons as protons, and it's the force of attraction between the positive and negative charges that prevents the electrons escaping. Each type of atom is identified by the number of protons and electrons it has. A hydrogen atom has just one proton and one electron. An oxygen atom has 8 protons and 8 electrons. An iron atom has 26 protons and 26 electrons, but this is not enough to explain the behaviour and properties of most substances.
Okay, so when we look at atoms and the number of protons and neutrons and electrons that are in the atom, I like to think of an acronym called Ape Man Ate a Big Mac. So here we see an ape man and he's going to eat a Big Mac. Well, what does that mean? Well, first we're going to start off with the Big Mac part. Big Mac means that the symbol for an element is written as a big capital letters, okay, with the first letter being capital and the second letter being lowercase if there is a second letter. Okay, so that's the big part. Mac means that the two numbers that you see, the first number on top is going to be the mass number. It starts with the M, so Mac. The second number is going to be the atomic number, and that's on, those are both on the right side. The C stands for charge. Now most atoms are neutral, and we're going to see a little later on when atoms have charges and how they behave. But if the atom does have a charge, the charge is going to be in the upper right hand corner. But for americium that we're going to talk about, there is no charge. We're going to talk about neutral atoms first. Well, ape man. What ape man means is the A stands for the atomic number, and the atomic number is equal to the number of protons, which is equal to the number of electrons in a neutral atom. So they have the same number of protons and electrons, and you saw that from the video. That's represented by the atomic number, which is the 95. The man part is the mass number, which is the top number, minus the atomic number, which is the bottom number, is going to give you the number of neutrons. So let's look at that applied. Let's look at helium. Helium has a mass number of 4, an atomic number of 2, and we get that from the periodic table. Okay, so if we apply this concept of ape man, we can see that the 4, which is the mass number, subtract the 2, which is the atomic number, and that's going to give us the number of neutrons. Okay, so protons, the atomic number, the bottom number 2, is equal to the number of protons. So we see here we have 2 protons, and we calculated that we have 2 neutrons, 4 minus 2, and protons are equal to electrons in a neutral atom. Some atoms have what we call an isotope. So if we were to look at helium has one naturally occurring isotope, and an isotope is just a variation of a helium atom. And this happens to be helium-3. So it has a mass number of 3. It has the same atomic number of 2. So if we apply the ape-man concept here, atomic number is equal to protons is equal to electrons. Okay, so we know it has 2 protons, so we need to find the number of neutrons. So we take the 3, which is the mass number, we subtract the 2, which is the atomic number, and that's going to give us 1. So if we look at helium's only naturally occurring isotope, or a version of helium, we can see that it has 2 protons, 1 neutron, and 2 electrons. So how does this differ from the most abundant form of helium that we saw before? Well, the number of neutrons is the only difference. So how do you get isotopes? Isotopes are formed when an element loses a neutron.